So there's some other array stuff that I want to show you guys. These right here are single-dimensional arrays, but I want to show you what a two-dimensional array looks like in memory. A static two-dimensional array is the easiest to explain syntactically. It looks like this. Char arrays can exist of any type that you choose, even classes and structs. But I'm going to make a map here. I'll call it a map static. It's going to be 5 by 7. Actually, instead of a char, I'm going to make it an int. I'm going to initialize some data for it so that we can see where all the different elements belong in memory. For row equals 0 while row is less than 5. You know what, I don't like 5 in there, that's a magic number. Let's do const int height equals 5, width equals 7, height width, row is less than height, and call equals 0 while call is less than width. I will do map static row call equals row times width plus call, which will make it so that element 0, 0 is equal to 0, because 0 times width is 0, and 0 plus 0 is 0. Everything on the first row will have 0 for this, and we just add its column index. Everything on the second row, which is on row index 1, will add width to it once. Everything on the third row, which is row index 2, will add 2 width to it. If I want to test it out and see how it would print, I'm going to do this, and wait, I'm using put char /n printf %4d map static row call get ch down here. This is just test code just to make sure that my two-dimensional array is indeed being set correctly by this for loop and that it can print correctly with this for loop. Yeah, that looks good to me. It's printing in columns of 4, 1, 2, 3, 4, then there's a space here, and then another column of 4, then a space, then another column of 4, just like this printf is telling it to. If we look at this in memory, let's go ahead and set pointer to the address of map static char star What's this? Char cannot be used to initialize an entity of type char star. Here we go. Wait a second. Whoops. I made a typo here and it ended up not getting caught. I intended that this would crash, but it didn't. Interesting. How about that? That also works. What about this? Nope. That does work. Interesting. So the reason I'm confused about this is because map static is a constant address. Typecasting it as a char just means that I'm taking that constant address and treating it as though it were a character array rather than whatever type that it thinks it is, which is, in this case, a static integer two-dimensional array. This should actually cause a problem because this would be grabbing the address of a constant, which shouldn't really, I mean, if it were possible, then it would give me the address of some integer someplace or of some other value, and then I would be looking at the address of that integer rather than the actual data. This right here is the 2D array that I expected. This right here is element 0, 0. This is element 0, 1, 0, 2, 0, 3, 0, 4. So these 4 bytes are 0. This is 1. This is 2. This is 3. This is 4. And all of this data is in one big contiguous line. It's all in a row. Even though this is supposed to be a 2-dimensional structure, it's all just in one row, and that's just because we're in memory, and everything in memory actually ends up being one-dimensional. But because of the way that the compiler works, it's able to treat this one-dimensional array in a 2-dimensional way at the source level, even though at the code level it's all one. Whoa, what's going on here? Close. What was that? Oh, it's because I pressed space. Space. Yeah, there we go. I had pressed space, and then, yeah, that's what that error was. Anyway. Let me go back to main. So either no address here or an address here has no effect because a static 2D array is treated very differently by the compiler than a pointer would be. So let me show you what this would look like if I had done it as a 2-dimensional dynamic array. Int star star map dynamic equals new int star height for int row equals 0, while row is less than height plus plus row map dynamic row equals new int width. While I'm at it, I'll go ahead and initialize everything. And then I'll print it out. Printing it out looks the same as it does for the 2D array, except different variable name. And just to differentiate the dynamic array from the static array, I'm going to make the values a little bit different. I'll have them plus A, so that this will start counting from the letter A. Let's see what that looks like. Oh, and of course we don't see them as letters here, we see them as numbers because of that. So how about this? Okay. So this right here is the static array, and this right here is the dynamic array. And I want to see what the dynamic array looks like in memory, so I'll do map dynamic. I want to go to the address of the pointer. So when I do that, it takes me to the pointer that points at the 2-dimensional array. If I press space, it takes me to the first dimension of the 2-dimensional array. And this 2-dimensional array was created to be an array of integer pointers height long. So there's height number of pointers here. There's 5 of them. 1, 2, 3, 4, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 4, 1, 2, 3, 4, 5. So there's 5 pointers here, and each one of these are pointers, and if I go into one of these, space, then it takes me to the data that belongs to that row. So a dynamic 2-dimensional array is clearly very different than a static 2-dimensional array. Also, let me go back down here. The address of map dynamic gave me the address of the pointer pointing to the 2-dimensional array. If I take this off, it will instead take me straight to that first dimension of the 2-dimensional array. Here we are, and we can see the 1, 2, 3, 4, 5 pointers there. And here we can see that there are individual arrays that are 7 long, and there's 5 of them. Here we can see A, B, C, D, E, F, G, that's the first 7. And then we can see H, I, J, K, L, M, N, O, that's the next 7. O, P, Q, R, S, T, U, that's the next 7. And we can see them here in heap. Everything is in memory someplace. And here in heap, you can see all the stuff that we've allocated with new. In fact, if I scroll up, this is the address of those first 5. Of those first 5 integer pointers that point at integer arrays. And then down here, we have those actual integer arrays. and A is clearly not a pointer. Whoops. So we can see that dynamic arrays are different than static arrays. But dynamic arrays and static arrays are closely related. Both of them use the array notation, and it looks the same when you use it in the syntax. When you do it with a static array, that syntax means something very slightly different, and the size of operator works differently. So for example, printf, if I did dynamic and static, the size of map dynamic is this is going to be 4 because a pointer is 4 bytes big, and the size of map static, I think this is going to be 34 times 4. Let's find out. Yep, so dynamic points at a pointer, which is just 4 bytes, but the static points at 140 bytes. Okay, that's a lot of output that we're getting here. I'm going to delete that output. Another difference between the static and the dynamic is that you never have to delete the static array because the static array exists on the stack, and when the function is finished executing, all of that stack space gets overwritten by the next function that uses that stack space. But you do have to deallocate a dynamic array, and when you want to deallocate a dynamic array, it would look like this. Delete that, and then delete this guy. So if you notice, with this deallocation of the dynamic array, we delete the child elements of the array first. And we have to do this because if we deleted the parent element, the highest level dimension first, then we would lose reference to all of the low level dimensions. So we have to do it in reverse order from how it's allocated. Let me just get rid of this for a second. And here we can see that first the higher height dimension is allocated, and then from that height dimension we can attach the width dimension, and when we delete it, first we delete that width dimension. These are the width dimension elements, and we delete those first, and then we delete that height dimension. But I don't want this to get deallocated until later. Okay, let me get rid of that getch, because there's some pretty cool things that we can do with this memory viewer still, and I want this two-dimensional array to stick around.